I'm Golden Yashwin. I'm here to present energy efficient routing in ad hoc and wireless sensor network course. On completion of this video, students will be able to explain what is energy efficient routing and how it works. So, energy efficient routing. In most sensor network scenarios, these devices acquire data from the environment and send it to the other nodes for further processing and analysis. So, when such destinations are not within the radio range of the source node, then intermediate sensor nodes are used as relays. So, for energy efficient routing, the shortest path algorithm is modified to obtain routines with minimal total transmission power. So, what qualifies as a good cost metric in general depends on the precise intention of energy efficient unicast routing. So, in fact, these are the various aspects of how energy or power efficiency can be conceived of in a routing context. So, in this figure, we can conclude include energy cost and available battery capacity per node. Then various factors considered for energy efficient routing. First one is minimize energy per packet or a bit per bit. So it is required to look at the total energy required to transport a packet over a multi-hop path from the source to destination. The goal is then to minimize for each packet this total amount of energy by selecting a good route. So minimize the hop count while typically not achieving this goal as routes with few hops might include hops with large transmission power to cover large distances, but be aware of distance independent constant offsets in the energy consumption model. So, nonetheless, this cost metric can be easily included in standard routing algorithms. So, it can be lead to widely differing energy consumption on different node. Then maximize network lifetime. So, in a WSN's task is not to transport data but to observe energy efficient transmission is at best a means to an end, and the actual end should be the optimization goal. So, the network should be able to fulfill its duty for as long as possible. So, which event to use to conclude the end of the network's lifetime is, however, not clear either. So, several options exist, like time until the first node fail, or time until there is a spot that is not covered by the network. That means loss of coverage, a useful metric only for redundantly deployed networks. So, then a time until network partitioning. That means when there are two nodes that can no longer communicate with each other. Then third one is routing considering available battery energy. So while maximizing the network lifetime is clearly a useful goal, so it is not immediately obvious how to reach this goal using observation parameters of an actual network, as the finite energy supply in nodes batteries is the limiting factors to network lifetime. So it stands to reason to use information about battery status in routing decision. So some of the possibilities are maximum total available battery capacity. So in this, choose that route where the sum of the available battery capacity is maximized without taking needles detours. Then minimize battery cost routing. So instead of looking directly at the sum of available battery capacities along a given path, MBCR MBCR means minimum battery cost routing. Okay, so instead look at the reluctance of the node to route traffic. So this reluctance increases as its battery is drained. For example, reluctance or routing cost can be measured as the reciprocal of a battery capacity. So then the cost of a path is the sum of these reciprocals, and the rules is to pick that path with the smallest cost, since the reciprocal function assigns high cost to node with low battery capacity. This will automatically shift the traffic away from routes with nodes about to run out of energy. Then the third one is minimum to maximum battery cost routing. So this scheme follow a similar intention to protect nodes with low energy batteries resources. Instead of using the sum of reciprocal battery levels, simply the largest reciprocal levels of all nodes along a path is used as the cost for this path. So then again the path with the smallest cost is used. So in this sense the optimal path is chosen by the minimizing over a maximum. So the same effect is achieved by using the smallest battery level along a path and then maximizing over these path values. So and then the next one is conditional max to minimum battery capacity routing. So this option is to put condition upon the actual battery power levels available. If there are routes along which all nodes have a battery level exceeding a given threshold, then select the route that requires the lowest energy per bit. So if there is no such route, then pick that route which maximizes the minimum battery level. Then next one is minimize variance in power levels. To ensure a long network lifetime, one strategy is to use up all the batteries uniformly to avoid some nodes prematurely running out of energy and disrupting the network. So hence routes should be chosen such that the variance in battery levels between different routes is reduced. Then the last one is minimum total transmission power routing. So without actually considering routing as such, looked at the situation of several nodes transmitting directly to their destination, mutually causing interference with each other. A given transmission is successful if its S and or exit to give threshold. So the goal is to find the assignment of transmission power values for each transmitter. So given the channel attenuation metric, okay, such that all the transmissions are successful and that the sum of all power values is minimized. MTPR is of course all also applicable to multi-hop networks. Then the last energy efficient routing is a direct performance comparison between this concept is difficult as they are trying to fulfill different objectives. So also while these objectives are fairly easy to formulate, it is not trivial to implement them in a distributed protocol. So that judicially balances the overhead necessary to collect routing information with the performance gained by clever routing choices. Thank you. Thanks for listening.